Dr. Roussev, and I'm an 8th grader at First English Language School in Sofia, the capital city of Bulgaria. Today I'm here because I would like to show you my presentation, which is about how to solve this equation. Then we're going to do something more interesting and exciting. We are going to include this equation in a system, but we need one more equation for an existing system, so you can see the other equation as well. I think we're ready to begin with this equation. Can you see it clearly? It includes two absolute values and a parameter. I suppose that when you were at my age, you may have had some troubles with solving such a difficult, I can say, equation, because probably you didn't know what an absolute value and what a parameter meant. But this is why, firstly, I want to begin with explaining the exact meaning of the absolute value and of the parameter in lots of ways, and now you're going to see the first way for the absolute value. It's a definition. The absolute value of a number may be thought of its distance from zero. And now these words are expressed in this graph, and this graph is a function. The function is y equals the absolute value of x. And what it really means in practice, the absolute value can be of either positive or negative number. However, absolute values always equal positive or non-negative numbers, so zero doesn't change. For example, the absolute value of -1 equals the absolute value of 1, which equals 1. And now our point of view, what is the absolute value really with no so mathematical things, simply our point of view. But here's an important note for you. My red x means the positive equals the non-negative x, and the blue x equals the negative x. What is more, for this situation, imagine that blue and red are two opposite colors. So now I'm going here to show you what it really means to solve this. Simply to remove the lines of the absolute values. So we're going simply to take them and to put them where? Simply on the x. And now we don't see any difference because it was a red x. We simply have taken the lines of the absolute value, and now you see the x is absolutely the same. It's the red one. So this is why when we have the x and it is greater than equal to 0, it doesn't change. It is the same, which was inside the absolute value. But now, on the other hand, here we have inside the negative x. Okay, we are beginning with the same way. It is the same again, but we have the lines of the absolute values. We are taking them, and as you can see, we now have the red x. Here it was blue, and now it is red. And what I said was that red and blue are opposite colors. So we have negative, and now we have the opposite of a negative number, and it's the positive one. So here, when we have x which is less than 0 when it is negative, we have the opposite. We have a positive one because what I said was absolute values always equal non-negative numbers. Now, the parameter. Here's the definition. It is one of the independent variables in a set of parametric equations. Yes, I suppose that for some of us it doesn't make sense because it really sounds very unnatural or difficult, but the parameter, in practice, usually we just choose one of the first letters of the Latin alphabet to name a parameter. And the parameter can be any number. It can be positive, negative, or it can equal 0. So this is the parameters, something with the difficulties, with the complex explanation. So I hope that all of us now know what a parameter and what an absolute value is, so we can begin solving this equation. We are going to solve it in two ways. One of them is the old one which was used by the great mathematicians in the past and by most of us at school. But the good mathematicians trust two ways, not only one. So our second way is using the interactive application GeoGebra. So first, we have to look carefully at the equation before starting solving it. And what we see is we have a parameter. I said it can be any number, but in this situation we have the parameter fixed, because here we have the addition of two absolute values, and or simply the addition of two non-negative numbers. Can it equal a negative number? No, of course. So this is why the parameter a is greater than equal to 0. And here are the four cases in the equation. The first case, when both x and y are greater than equal to 0. You can see the steps. And we have y equals a minus x, and here it is the graph in the Cartesian coordinate system. Now we have the second case when x is greater than equal to 0 and y is less than 0. Here, as you can see here, we have y equals x minus a, and we are in this case, which is true for the fourth quadrant in the Cartesian coordinate system. As you can see, the answers expressed there. The third case, when x is less than 0 and y is greater than equal to 0. We look here. We have a equals a plus x, and we are in the second quadrant. Now the fourth case, when both x and y are less than 0, we have y equals a negative x plus negative a. Here is the answer, graph drawn on in the third quadrant. And this was the equation. And now let's conclude the solutions. What we have is a very interesting geometric figure, and it's simply a square. And you can see it becomes bigger as the parameter is bigger. And now let's enter the system. We have the already the solved equation and the other equation. We're going to see what happens here. We are first looking at the equations. What we have to do first is the same as what we did previously, we make the parameter fixed, a fixed. A is greater than or equal to 0. Now all of us know the reason. And then we're going to solve the system using mainly the interactive application GeoGebra. And here's the first case, when both x and y are greater than or equal to 0. You can look at the solution. And here we have x equals a phrase including the parameter. We have x equals a minus 0.5. But we're in the case when x is greater than or equal to 0. So we have to make this phrase greater than or equal to 0. And here it is solved. And we have the parameter a greater than or equal to 0.5. Here's the second case, when x is less than 0 and y is greater than or equal to 0. Here are the steps. And now we have something very interesting. X multiplied by 0 equals something. And it has a dependable parameter a, 2a minus 1. Here we have two more cases. When this phrase equals 0, and if it equals 0, we have x multiplied by 0 equals 0. Everything multiplied by 0 equals 0. So we have infinitely many solutions. But on the other hand, if 2a minus 1 doesn't equal 0, it is something. But x multiplied by 0 just can't equal something. So we have the second a case. I've already explained it. Here the phrase doesn't equal 0, so the system has no solution. But on the other hand, we have the second B case, when a equals 0.5, and we have infinitely many solutions. Here's the third case, when here is the sorry, apologize to everyone. This is the answer, the graph of the second case, when we have a segment and a line. The segment and the line are parallel at all the time except for here, when they are the same. This is why we have infinitely many solutions. The third case now, when both x and y are less than 0, you can see the steps. And now as the solution of 0.5, we have a phrase. We've already had a phrase, so we exactly know what to do. We simply look at y. It is less than 0 in our case, so 0.5 minus a must be less than 0, and here the solution a is greater than 0. The final case, when x is greater than equal to 0 and y is less than 0, you have to look at the solution. And we have here x is multiplied, x multiplied by 0 equals 1. Equals 1, it just doesn't make sense. We've already know y, and here is why the solution has no system. So the segment and the line are only parallel. They don't cross at any point. And this was the system. So let's conclude the solutions. You can see them. And here are two more ways for concluding the solutions using GeoGebra. And another graphical showing of the results when it equals 0.5, and two cases when the parameter is greater than 0.5. And this is actually the end of my presentation. Firstly, I hope you've liked it. What is more, I hope you've understood it. Finally, but the biggest of importance, I do hope that you've realized mathematics isn't so difficult or boring. It can be interesting and exciting if you want, if you have the desire. And almost everything can be solved. Almost everything is possible. Even meeting Einstein. Even this is possible.